In this video, we'll look at solving inequalities. And here we have a linear inequality in one variable. So we just have one variable, which is x. I do want to do a quick review, though, before we start solving of when we have to flip the sign, right? The only difference in inequalities than an equation is sometimes we have to flip the inequality sign. So let's say flip the sign if, and there's two times, you multiply or divide by a negative, or if you want to write the variable first, which you should do if you only have one variable. It should be written first before you graph it. All right, so an example of dividing by a negative, let's say I had negative 2x is greater than 4. So to solve that, I would have to divide both sides by negative 2. That would give me x. And then the reason you have to flip your sign is because what you had to start with over here is positive. But when you divide by a negative, your answer is now negative. So when you change the sign, like when you change the positive or negative, that also changes the inequality sign. So because I'm going to take 4, but I'm going to divide it by a negative 2, and my answer is a negative 2 now, I need to flip that inequality sign to less than. So the reason with the multiplying or dividing by a negative is because that negative changes the positive or negative, which means it changes the less than or the greater than. And then if you want to write your variable first, so let's say we solved and we got 5 is greater than x. In order to graph it, we want to write x, and then we want to flip that around. So notice here it's pointing towards the x. We still want it pointing towards the x when we rewrite it, so we flip it around. All right, so let's go and solve now that we've reviewed that. So there's that inequality sign that separates, it's kind of like the equal sign. So I'm going to subtract the 3x over. Gives us 2x minus 7 is greater than positive 9. And then we know we'd add the 7 over. 2x is greater than 16, divide by 2. And in this case, we're not dividing by a negative, so we do not have to worry about flipping our sign. We have the variable first, so x is greater than 8. And then it does ask us to graph the solution set. So if we were to write it in interval notation, we want to say that x is greater than 8. So it starts at 8. It doesn't include 8. So a parenthesis at 8, and then it can go on forever. So then it goes on to infinity with a parenthesis. So I know it doesn't ask you for that, but I want to just continue to review that. And if we were graphing, we'd have our number line. And we would have a parenthesis. So we're used to putting like an open circle on 8, but our new equivalent or a different equivalent to open circle is a parenthesis. So we're going to put a parenthesis on 8 and then everything greater than that. So we're going to draw a nice thick arrow with, or sorry, a nice thick line with arrows at the end. So there's our graph for that solution set. So we did not have to flip the sign on this one at all, and that majority of the time you don't have to. But we do want to be aware of when we do need to. All right, now here we have what's called a double inequality. And basically it's like if I have two separate terms that are both compared to the same thing. So these are both being compared to 5x minus 2, 5x minus 2. I can write the 5x minus 2 once and then write my negative 4 is less than or equal to on the left side and my less than 7 over there on the right side. So it's just combining them into that double inequality. So then to solve, we have to pick them apart. So we have to go backwards. So here, if we want to solve negative 3 is less than or equal to 6x minus 1 is less than 3, we need to split it into our first half, which is negative 3 is less than or equal to 6x minus 1. And then our second half, which is 6x minus 1 is less than 3. So the inequality sign splits the halves, if you want to think about it that way. And then we just have two inequalities now to solve. So this, if we add the 1 over, gives us negative 2 is less than or equal to 6x. Here we just have to divide by 6, so the sign is not going to change. Please do not flip the order here yet. So if I simplify negative 2 divided by 6, that's negative 1/3 is less than or equal to x. And I'm going to now flip that around so I can use whichever one of these I need. But normally we want to write the variable first. So that's what it would look like if we wrote the variable first. X is greater than or equal to negative 1/3. And then if we want to solve here, we'd add the 1. 6x is less than 4. Divide by 6. Again, we'll get a fraction. No flipping the sign here. We did not divide by negative. Here that fraction simplifies to 2/3. So if we want to graph this solution set, it's greater than or equal to negative 1/3. So I know that's think about that as the bottom end. And then it's less than, so this is the top end. So if we're doing thirds, let's do 0. Let's put 1 and negative 1 and then split it into 1/3, 2/3, 1/3, 2/3. So then our negative 1/3 is our bottom end. And if we look at the inequality, it could be equal to. So we're going to put a bracket at the negative 1/3. And then the 2/3 is our top end, and that inequality sign is only less than. So that's going to be a parenthesis at 2/3. And then, of course, we would fill in everything in between. If we wrote this in interval notation, we would have a negative 1/3, and that's a bracket, comma, 2/3, and that's a parenthesis.